Okay, so can anyone please confirm whether my voice is audible or not? You can write it in the chat box. Okay. So, hello everyone. Uh, I'm Gitanjali. I'm a PhD scholar from IT Delhi, and I'm the TA for this course, which you already know. It is Foundation of Classical Electrodynamics. So, the main purpose of the session is to go through the lecture contents, as well as uh, uh, covering the lecture contents. I will also cover few problems that will be helpful for you to solve the weekly assignment that has been published in the NPTEL website. So we will meet on every Friday, same time from 6 to 8. So, and feel free to ask me any question whenever you have doubt. You can write it in the chat box, or I will unmute you so that you can ask your question. And one thing I would like to suggest is to whenever I am solving the problems, so please try to solve it side by side. If possible, please solve it side by side so that it will be helpful while you don't have to go through it again when the lab session is over. So you just can look it over whenever you get free time. So please try to solve it and uh, while solving the problems, if you feel any doubts or if you have any conceptual doubt in the lectures or whatever doubts you have regarding this course, then you can ask me during this lab session or there is also I think, a group where you can ask your problems and problems related to any assignment or the lab session. Okay, so let's wait for 2 minutes more so that students can join. Then I will start. Okay. So let me reiterate. So I am Gitanjali. I'm a PhD scholar from IIT Delhi, and I am the TA for this course. And whenever you have doubt regarding this course or regarding any assignment or you have doubts in the problems that I've solved, then you can ask me during this live section or you can write it in the Google group. So, and whatever doubts you have, then you can feel free to ask me anytime. Okay. So, okay, let me start the session then. So, in this week, we have basically focused on what is the fundamentals of what is the foundation required for studying the electrodynamics. So, it's basically all about what is vector, what is scalar, what is the different types of coordinate system that we use most of the times, and what is the transformation that is associated with this vector transformation or unit vector transformation. These are all the things that we have seen in this week. So it may seem trivial for like this this week content, but this is the main foundation for this course. So please understand all the laws, all the rules for the transformation or uh, the laws you will see also what are the divergence law, what are the curl. So these are critical to use in your future contents that you will see in the later weeks. So please try to solve it as much as possible so that your fundamentals will be clear. Okay. So let me start. I will. So the live session is like this. I will In first few minutes, I will cover whatever that is taught, briefly cover whatever taught in this week. Then I will solve the problems. Okay. And one thing is the assignment one is already it's already published in the NPTEL site. So I'm not going to solve the assignment one because it's the solution is not being released yet. So after the solution is released, then if you have any doubts, then you can ask me in the next live section. Okay. So let me start. So we have two types of physical quantities. One is scalars and other thing is the vector. So scalars, the normal definition is the quantities which has only magnitude. It doesn't have any direction. So this is the definition that we typically use to define a scalar. And one of the example of the scalar quantity is temperature. And vector, you already know it's basically it's the definition of the quantities that is magnitude as well as the direction. But uh, you can see this definition is not it's not a full definition. So it is like the vectors it have magnitude, it also have direction, but it also have to follow certain transformation law that we'll see in the meantime. So this transformation law, it is similar to how the displacement behave whenever you change the coordinate system. Okay. So one of the example of the vector quantity, it's electric field, magnetic field, displacement, or uh, heat flow in a system. Okay. So these are the basically two types of physical quantities that we have. And to define the vectors, we typically use three most different types of coordinate system. One is the Cartesian coordinate that you already know. It is mostly used, so it is XYZ coordinate system. Next one is the cylindrical coordinate system, and the third one is the spherical coordinate system. So one minute. So if you look at the Cartesian coordinate, so this is how we typically represent a Cartesian coordinate system. So this is one of the example of a right-handed Cartesian coordinate system. You also have left-handed coordinate system, but most of the cases we use this right-handed coordinate system. So in cylindrical coordinate, we have rho, phi, and z. So these are the basis vector of cylindrical coordinate system. And for spherical, we have r, theta, and phi. So to represent a vector in Cartesian coordinate system, we have, so we can use the unit vector of Cartesian coordinate, which is I cap, j cap, and k cap. So, sorry. So this is how you can represent the vectors in Cartesian coordinate system. So these are the projection along x, projection along y, and these are the projection along z. And the limits for the x, y, and z, it is varying from minus infinity to infinity. Similarly, in the cylindrical coordinate system, we have rho, phi, and z. So, and the unit vector, you can represent it as rho k, phi k, and z k. And this is how you can represent a vector in a cylindrical coordinate system. So, in the projection along rho direction is arrow, and along phi it is a phi, and along z is a z. And rho it is typically varying from 0 to infinity. Phi it is like the rotation in a plane. So it will vary from 0 to 2 pi. And z, it can have values from minus infinity to infinity. So my voice is audible to everyone, right? I think so. Okay. Yes, then let me continue. Okay, thank you. For spherical coordinate, we have r, theta, and phi. So this is how you can represent a vector in a spherical coordinate system. And the limits are r can vary from 0 to infinity, and theta can have value from 0 to pi, and phi is it can vary from 0 to 2 pi. Okay, so this is okay. So the limit it can vary from situation to situation. Like if you are considering a sphere, then the theta limit it would be 0 to pi. But if you consider a hemisphere, the limit will change from 0 to pi by 2. Similarly, depending on the situation, this limit can vary. So just look at the questions, the situation you have been asked for. And depending on it, you can change the limit from your from you can vary the limit. Okay, and so this is how the cyclic order of the Cartesian coordinate. So if you go from x to y and take the cross product, you will get z cap. From y to z, if you take the cross product, you will get I cap. And for cylindrical, this is rho phi z, and for spherical, it is r theta and phi. Okay. Besides, after defining the basis vector of a coordinate system, so how can you define the length element, like the infinitesimal small element, so that you can further calculate what is the electric field there, what is the magnetic field there, or what is the vector potential, or whatever the question is asking for. So for this, what we have for Cartesian, this I think you already know. We can represent the length element. This is this. So in x direction, we can have length element dlx, y direction it is dly, and z direction it is dlz. So dlx is nothing but dx, dly it is dy, and dlz it is dz. So this is trivial for the Cartesian one. But in the cylindrical one, you can write it in a similar pattern. You can write it as dl as dl rho, length element in the rho direction, phi direction, and the z direction. In rho direction, this is direct, it is d rho. But in the phi direction, if you go through the lecture, it is rho d phi. So it's like the vector is rotating in the plane. So whenever you change an angle by d phi, so by a small lemma, then the arc it will cover rho d phi. And for the z direction, it is also direct. It is nothing but dz. Okay. This is for cylindrical. Now for the spherical one, in the r direction, the length element, it is also trivial. It is 0. And in the theta direction, so whenever it is rotating in this direction, theta direction, so this will be r d theta. And for the phi direction, that is the in plane rotation, we have r sin theta d phi. Okay. So these are the length element for different coordinate system. Now, if you look at the surface element for the Cartesian one, you can, so this is the general definition. So if you look at the length element in x direction, that means we want to find out a area vector which is oriented in the x direction. So that means this area vector, this area element, it will be in the yz plane. So that is why we'll take cross product of length element in y direction and z direction. So this is dy I cap, sorry, z cap, and this is dz k cap. So area element in x direction is nothing but dy dz k cap. Okay. Similarly, it is also trivial for y direction and z direction. Y direction means the area element, it is lying in the zx plane. So that is why you will take the cross product of length element in z direction and length element in x direction. So this is dz dx j. So for the z direction, the area vector is in xy plane. So this will be dx dy, and the direction is kk. Okay. So this is for the Cartesian one. For cylindrical one, we have, let us say, we want to find out what is the area vector in the r cap direction. So that means if I want to, so let me, so you have cylindrical coordinate like this, and this is the rho direction, right? And you want to find out the area vector in rho direction. So that means you have to take the cross product of area element in phi and z direction. Okay. So this is dl phi and dlz. dl phi, if you already know the length element in phi direction, then it is easy to find out. So this will be rho d phi dz rho k. So please go through all these small fundamentals, because in future it will be helpful. Okay. For phi direction, you have to take the cross product of area element in z direction and rho direction. So z direction it is dz, and rho direction it is d rho. So that is why it is dz d rho phi k. And for z direction, we have to take the cross product of rho and phi. So this will be d rho. And phi direction, if you remember, this is rho d phi. So we have to take rho d rho d phi. Okay. For spherical one, let me quickly go through it. For r direction, it is the cross product of theta and phi. For theta, if you remember, this is r d theta, and the length element for phi is r sin theta d phi. So that is why you have in the r direction, the area vector is r square sin theta d theta d phi. So if you in the r direction, if you integrate it, then you will get, if you take the full integration, then you will find out what is the surface area of a sphere. So theta limit, if you know, you already know it is from 0 to pi, and phi is 0 to 2 pi. So we will get 4 pi r square for the surface area of a sphere. And for theta direction, this is the cross product of dl phi and dl rho. So this will give r sin theta d phi dr theta. Phi direction, you have to take the cross product of r and theta. So this will be r dr d theta phi k. Okay. Okay, let us see the volume element. Volume element, you get it by taking the scalar product, scalar triple product. So if you remember, we have two types of triple product. One is scalar triple product and one is vector triple product. Scalar is like A dot B cross C. So the physical significance of this cross product is it gives the uh, volume of a space, volume of a element that is closing uh, that space. Okay. Okay. So for Cartesian, this is direct. It is dx dy dz. For spherical, it is r square sin theta d theta d phi, and for cylindrical, this is rho d phi d. Okay. And as I said in the first slide, so vector is nothing like it. It's also a magnitude as well as it is direction. Besides that, it also have to satisfy a condition that it should follow a certain transformation law. So so we'll see the what is the unit vector transformation law for a vector. So when you go from Cartesian to cylindrical, that is from XYZ coordinate system to rho phi z. So in Cartesian, you can write it X is rho cos phi, Y is rho sin phi, and Z is remain unchanged. And for cylindrical, you can write in terms of Cartesian. That is, rho is square root of x square plus y square, and phi is tan inverse y by x, and z remains unchanged. And if you, so the total, the whole derivation, it has been derived in the lecture content. So if you have any doubt, please, if you have doubt in the process or in the derivation, you can ask me. Otherwise, let me just show what is the final result. Okay. So when you have rho phi z and you want to find out what is the unit vector in I cap, j cap, and k cap. So these two are related by this transformation matrix. This is, so first element is cos phi, minus sin phi 0, sin phi cos phi 0, and this is 0, 0, 1. And the inverse, that is, if you know the unit vector of, if you know the representation in Cartesian coordinate and you want to go into cylindrical coordinate, so this is the transformation matrix that is related to this transformation. And if you see the lecture, it is, this matrix is nothing but the transpose of the previous matrix. So if you take it as a T, so the transpose of this will give the matrix that is related to this inverse transformation. So this is, that is why we call it as a orthogonal transformation, which satisfy this condition. So the transpose is equal to the inverse of this matrix. Okay, and you can write you can uh, write the unit vector in terms of this expression. So this is related by this transformation matrix Dij, and we have the unit vector Ej. So this is how the unit vectors are related to each other. So now if you have a vector or if you have a physical quantity, let's say if you know the electric field or magnetic field in one of the coordinate representation, so you can find out what will be the corresponding expression in other coordinate system. So let us say you know what is the components in what is the elements or what is the projection of a physical quantity in the Cartesian one, and you want to find out in the cylindrical one. So for that, so this is what you know already. So you know what is the representation in cylindrical coordinate system, and you want to find out what is the Cartesian representation. For that, you can express what is the corresponding representation from rho to I cap. So how rho is related to I, phi is related to I and j, I, j, k, and z is also related to I, j, and k. So if you use the T matrix, we will get this final expression. Okay. And for the inverse one, like if you have a vector that you know in the Cartesian one, so you know ax I cap, ay j cap, and az k cap, and you want to find out what is the corresponding representation in cylindrical. So for that, you need to express this unit vector in terms of the unit vector of the cylindrical coordinate, that is rho, phi, and z. So I have replaced I with the corresponding expression, j with this expression, and k with this expression. So from that, we'll get a coefficient that is related to this will be arrow, and a coefficient that is related to phi cap, this is a phi, and a coefficient as it will remain unchanged like this. And in terms of matrix, we can write like this. Okay. So this is the matrix that we have that we can use whenever you go from one coordinate system to other coordinate system. And if you look at the matrix, this is nothing but the T matrix that we have seen in the earlier case. So if I say, so this is how Cartesian is related to cylindrical. So when you go from cylindrical to Cartesian, we use this matrix for the unit vector. But for the any vector, like any general vector like electric field, magnetic field, we can also use the same matrix. Similarly, for the inverse case, you can use the same matrix if you want to find out the corresponding expression, representation in the cylindrical or Cartesian. Okay, so you just need to remember only one of this matrix. Other matrix, the inverse matrix, you can get it by taking the transpose, and the vector transformation, it is also related to the unit vector transformation. Okay, so this is what I have already told. So this is related to this inverse matrix. Okay. Okay, while going through the content, if you have any doubt, then please feel free to ask. So I think I have muted everyone. So please use the chat box to ask your questions or any other query. Okay. Okay. So this is for while going from Cartesian to cylindrical. For Cartesian to spherical, you can use the same method. So like in Cartesian, we can write x is r sin theta cos phi, y is r sin theta sin phi, and z is r cos theta. The inverse is r is square root of x square plus y square plus z square, and phi, it is nothing but you have to take tan inverse of y by x, and theta, it is related to z by r, and r is nothing but square root x square plus y square plus z square. So for orthogonal transformation, we can use, so we have to like, if you know the what is the representation in the spherical one, and you want to find out what is the representation in Cartesian, you can use this transformation matrix, which is M. For inverse transformation, what you have to do, you just need to take the transpose. That is, you just make the column to row, just take it to row to column, column to row for the transpose matrix. Okay. In vector, it is also related to the same matrix, the matrix M that we have seen earlier. Okay. So this covers whatever we have seen in the first week of this course. Now I will start a few questions that is related to this concepts. Okay. The coordinate transformation, and what is the dot product, scalar product, and what is the triple product. Okay. So whenever I'm trying to solve the problems, please solve it side by side, so that if you have doubt in any of the step, then you can ask me on the spot. So the first question is easy. So I will suggest you to solve it first, then I will solve. Go through the question once. Where can I get the recording method? Okay, so you want the slides. So slide means, I think we're talking about the slides that the professor is using, right? The lecture content slide. So this will be shared by NPTEL team. It will be shared very soon. So please wait for some time, then it will be shared. Whatever slides the professor or whatever slides you are seeing in the lecture, it will be shared soon. And about the recordings, it will be because this is the first live section. So you will be getting one link where I will insert the link of this recording as well as whatever whatever documents I'm using, whatever problems I'm solving, this will be also shared in that folder. So we will get a link for that. But I think by next week you will get that. Recordings will be available once the session is over. Then just wait for one day. I will try to upload it as soon as possible. Then you will get the link and you can easily go through the live session if you miss any. Yes, until um, so live session will be every week on Friday, same time from 6 to 8. It's better to join the lab section because it's like it's where you can easily ask me any doubts you have. Okay, so please try to join the live section. Otherwise, in case if you miss the live session, then you will get the link for this tutorial, and you can go through it again. Uh, okay, so Dinakar, I think so. Okay, you are talking about the answer, I think. Okay, but I doubt. I think it's the wrong answer. So let me. Can you please recheck? I think in one of the dot product you may have misplaced the values. So this question is a bit easier one. So we have A, which is 4ik plus 3jk minus 2k. So I want this live section to be interactive. So please try to interact as much as possible. Okay. So this is what we have. We have vector A and we have vector B. So this is in the Cartesian coordinate system, and if you recall, in any coordinate system, the basis vector you are using, like the ik, jk, and kk. So these are orthogonal. So if you take the dot product of I with k, or let's say I with j, it will be 0. So it's like the delta operator. So delta is a, if they are equal, then you will get a value of 1, and if they are not equal, then you will get a value of 0. And these basis vectors are orthogonal, but similarly, rho theta y also orthogonal, and sorry, rho phi z are also orthogonal, and r theta phi also orthogonal. But I so the basis vector of two coordinate system, like if you take the dot product of I with rho, so this is not orthogonal. So if you recall the matrix, whenever you go from one coordinate system to other coordinate system, you can always, let's say you are going from Cartesian to cylindrical. So you can always write I with some summation of rho, phi, and z. Okay. So that is why these are not orthogonal to each other, but in the same coordinate system, each of these basis vectors, these are mutually orthogonal. So orthogonal, it means these are perpendicular to each other, and when you take the magnitude, these are 1. Okay. So you need to find out what is A plus B first. So if you recall A plus B, it is nothing but, so you need to add component wise. So this will give 6ik, 3 with minus 3, it will cancel. And for this, we'll get plus 4kk. And for A minus B, you will get let's 4 minus 2 ik plus 3 minus of minus 3. That is 3 plus 3 jk minus 2 minus 6. It will take plus k2. So this will give 2 ik plus 6 jk minus 8 k2. So when you take the dot product, a plus b with minus b. So for the dot product, it's like a delta operator. So only the similar component will add in the uh, perpendicular component, it will give a zero value. So we have a plus b I cap here. This is 2. Let me write it explicitly. So we have 6 I cap plus 4 k cap dot product with 2 I cap 9 plus 6 I cap minus 8 cap. So this will give 12. We don't have any j component, so this is 0. And we have k component, so this will give 32. So this is minus 20. So the value we'll get is minus 20. Okay. So I think this is clear. If not, feel free to ask. Otherwise, I will move to the next problem. Okay. So if not, then let us go to the next problem. Please go through the questions. Can anyone tell what will be the answer for this? You are given a scalar triple product and two vectors are given. Sorry, three vectors are given. A, B, C. So let me first read out the question. So if the scalar triple product of A, B, C, that is A cross B cross, sorry, B dot C is minus 2. For A, it is 2ik minus 3jk plus 4kk. So you are given A plus 4kk. Other vector B is given to you, ik plus 2jk minus 3k. And C is given, it is 3 minus ajk plus 5k. So you need to find out what is the value of A here. When you are given A cross B dot C is minus 2. Anyone? Yes. I think one of you have already solved. It is 4. So let me quickly go through it then. So A cross B, if you recall, this you can easily find out by writing this one. So you need to write each component. One is 2, minus 3, 4 for A. And for B, we have 1, 2, minus 3. So this will give IK. So you need to take the cross product. 9 minus 8 minus minus 6 minus 4 JK plus 4 plus 3. So this will give IK plus 10 JK plus 7 K. C we already know. This is C is CIK minus AJK plus 5K. For A cross B dot C is given, which is minus 2. So that means 3 with 1, it will give 3, minus A with 10, minus 10A, 5 with 7, 35. This is minus 2. From this, we'll get A will be 4. And this is 38. 38 will go this side, minus 40. So A will be 4. Okay. So let me go to the next question. Try to solve it first. So let me read out the question in case my writing is not clear to you. So you are given two vectors A, which is one is IK plus 4 JK minus 3K. And B is given is IK minus JK plus 2K. So you need to find out what is the area of parallelogram, which is diagonals A and B. These are the diagonals of parallelogram. So if you know what is the formula for the area of parallelogram, then you can easily find out it. So area in parallelogram it is, if you recall, it is A cross B. Okay. So area will be 5 square root B. Yes, it is right. So you have A cross B. And finding the magnitude of A cross B. So this way already saying how you can calculate the cross product of two vectors. So this is nothing but IK, JK, KK. And the components of A is 1, 4, minus 3. This is 1, minus 1, 2. So this will give 5 IK minus 5 JK minus 5. Area is the magnitude of this. The magnitude of this is nothing but 5 square minus 5 square plus minus 5 square. So this is 5 square root. Okay. Okay. So let us move to our next problem. So let me read out the question first. It is asking to find out what is the, okay, you mean this question? So do you have any doubt or you just want to see what is the steps? Okay. So, okay, so let us move to our next problem. The next one, we need to find out what is the projection of a vector P on another vector Q. So you are given P is 1ik plus 3jk plus root 6ak. And another vector Q is given. This is 3ik plus 2jk plus 2 root 3ak. And you need to find out what is the projection of vector P on Q. So quickly calculate it. Okay, so one of you have already calculated 9 plus 682 by 5. Okay, so let me show the steps. So you have two vectors, one is P, one is Q. And for projection, what we need to find out is what is the angle between them. Or I think the angle is not required also for the projection. So if you have this type, then what is the projection of P and P on Q? It is P cos theta. And if you recall the definition of a dot product, so when you take the dot product of two vectors, this is nothing but magnitude of P, magnitude of Q cos theta. So that means P cos theta, that is the projection that you need to find out, is P dot Q divided by mod of Q. So you just need to find out what is the dot product of P with Q and what is the magnitude of the Q vector for the projection of P on Q. Similarly, for Q on P, you can take it as Q cos theta, which is P dot Q divided by mod P. So let us see. What does projection actually means? Okay, so projection, it's like so when it's like if you take the mathematical meaning. So if a vector that is oriented in another direction and if you have a vector that is oriented in another direction, you want to find out how much contribution of this B vector is along this Q direction. So for that, we need this projection uh, vector. Another meaning, if I recall, mm, one is how much contribution of this vector is along Q direction, and if I recall any physical meaning of projection vector, okay, so let me go through the any if it has any physical meaning or not. As far as I recall, so this is just to indicate what is the amount of a vector it is along one of the in another direction. So it's like to express a vector, you need components, right? So if you recall, what is the vector representation of in Cartesian, in cylindrical, or in spherical? So if you recall, we generally write is AXIK plus AYJK plus AZK. So these are nothing but the projection. Projection of A along x direction, projection of A along y direction, and projection of A along z direction. So this projection, when you take the linear combination of this, then you can get the whole vector. So you will get the total expression of this whole vector. Okay, so it's like this. Similarly, in the cylindrical, you can take arrow is the projection of A with in rho direction. So this projection operator, I think physically these are used to, it's like to measure something, you need reference, right? So like you use scale to measure what is the uh, length of a paper or any, to find out the dimension. Similarly, for to write a vector, you need reference, and the reference here is the coordinate system. So to express a vector, we need coordinate system. These are generally used for reference. And in that coordinate system, we use projection vector to see what is the contribution in independent direction, in the orthogonal direction, like x, y, z, or rho theta pi, or sorry, rho phi z and r theta pi. If I came up with anything new, then I will let you know. Yeah, I think is this clear? Okay. So we were trying to solve what is the projection of P on Q. So this is P dot Q by mod Q. So we have P. So mod P, it is you just need to take the square root of 1 square, 3 square, square root 6. So this is root over of 16, which is 4. Uh, Try to uh, check whether you are getting the same answer that I'm getting. For Q, it is square root 3 square plus 2 square plus 2 root 3 square. So this is square root of 25. We will get 5. So now you know what is P, Q, and the magnitudes. For P dot Q, you need to take the multiplication component wise. 1 dot 3 plus 3 dot 2 plus 2 root 3 3 plus 6 plus 12. I think this will give 6 root 2. So 9 plus 6 root 2. So now we can easily find out what is the projection. Projection of P on Q. This P dot Q divided by Q. So this will give 9 plus 6 root 2 by 5 into 4. 20. Sorry. So we need to take 1, right? Q. So this is 5. And for Q on P, same, it will be 9 plus 6 root 2 divided by 4. This is the answer for the question. Okay, so let me go to the next problem. Go through the question once. So it says we have a cone which satisfies 3z square equal to x square plus y square in spherical coordinate system. So the cone will satisfy this. What is the corresponding value of theta in the spherical coordinate system? Please solve it first, then I will go through the detailed steps. If you have any doubt in any of the steps, please try to stop me at that moment so that I can solve it in the earliest time. Okay. So for this, we need to find out what is the theta. Please recall what is the how the theta is related to the Cartesian coordinate. It's only pi by 4. So you mean pi by 4. Sorry, pi by 3. Yes, it's correct. If we recall, okay, for spherical one, so we need to find out theta, right? So one thing you can do, express the Cartesian one in terms of the basis vectors of the parameters of the spherical coordinate. So if you recall, we have z in the spherical, it is r cos theta, x is r sin theta cos phi, and y is r sin theta sin. And the relation, it is given 3 z square is equal to x square plus y square. So that means we have 3 r square cos square theta is equal to x square plus y square. R square sin square theta cos square phi plus r square sin square theta sin square phi. You can we can take out a common factor r square sin square theta, and this is cos square phi plus sin square phi. If you remember, it is nothing but 1. And in the Left hand side, we have 3 r square theta, which is equal to r square sin square theta. So r square will cancel. We have 10 square theta is 3. So tan theta is square root 3. So theta will be tan inverse root 3, which is nothing but pi by 3. Yes. Yes, the answers are correct. So we will get option B, which is theta is pi by 3. Okay, so let us move to our next problem. So let me read out the question first. So you have rho phi z, these are the cylindrical coordinates. Write the equation of the loci, which is phi is pi by 6 and z equal to 4 in the rectangular coordinate or the Cartesian coordinate. In the first option, we have y is square root 3x plus, and z is 1. In option B, you have y equal to root 3x, z equal to 4. And in option C, we have x equal to root 3y, z equal to 4. And in option D, we have x equal to root 3y and z equal to 1. From this option, we can clearly guess because whenever we go from cylindrical to rectangular, the z component remains unchanged. So that means the answer will be either B or C. So let me know the answer first. Yeah. So you just need to see how the pi is related to y and x. Just recall the formula, or you can look at the schematic that I have drawn. You can easily get it from here also. What, it's one of what's loci actually means? Okay, so locus means the path, which is this value. This value remains constant along this path. Like phi will be remains as pi by 6 and z will remains as 4. This is what we mean by loci. Option C. Yes, you are. We will get option C. So Dinakar, I think you are clear about loci, right? Okay. So, as one of you have already calculated, so this is phi, it is tan phi, you can write it as. So, if you see this case, this is the phi angle, and this you can write it as tan phi is y by x. So, that means y is x tan phi is given pi by 6, which is tan phi by pi by 6 is 1 by root 3. So you will get x is root 3 times y. In the assignment also you can easily see which are the first try to find out which are the options which can be correct. So it's like for this case z equal to 1, it is not possible, right? So A and D are not the answer for this question. So only the solution will be either B or C, and the answer will be option C. Okay, so let us move to our next problem. Next problem, it will take few minutes to calculate. So you need to express a vector which is given in the Cartesian in a spherical world, and you need to find out what is the projection of this vector or what is the component of this vector in the radial direction. So let me write what is given to you first. So A is given, it is is I cap plus 2z j cap minus 8y k cap. That is Ax is given, Ay is given, Az is given, and in the spherical one, you need to find out what is Ar. So you can write A in spherical as A rho cap plus A5 phi cap plus. So for spherical, we take it as R, right? AR cap, A5 phi cap, A theta theta. So you need to find out what is A. So what you need to do? So you need to express all the components of this Cartesian in terms of cylindrical. So you need to express I, J, K in terms of rho, theta, and phi. So these are related by the matrix M or T, if you want to call it T. And also you need to check whether the X part does have any component along X. For that case, you need to also express XYZ in terms of R. So I did the same mistake. So this is R theta and phi. Okay, it will take some time to find out. Let me show the steps. Okay, so recall we have X. This you can write is R sine theta cos phi. Y is R sine theta sine phi. And Z, this is R cos theta. So for AR, we need to take 3x R theta phi. That is the component of phi in terms of R. 2z r theta phi jr, that is what is the component of say, or how you can write j cap in terms of r cap, and the last we have 8y r theta phi k cap. So find it, you just need what is the expression of I, J, K, how these are related. So if you recall that for spherical one we have sin theta cos phi cos theta. Can you go to the previous slide for the question? Okay, so you mean this one? Okay, one of you have already calculated what is the answer for this. The present seventh question. This one. Yes, and it. Okay, let me see the answer first. So, Dinakar, is it okay if I go to the next slide, or you want to take it? So, whenever for the coordinate transformation, I would suggest just remember one of the matrix. The reverse transformation, you can get it by taking transpose. So, no need to remember every other matrix. Okay. So, for spherical one, just remember this matrix, then you can get the what is the matrix for that inverse one. So we have sin theta, sin phi plus cos theta, sin phi cos phi. This is cos theta minus sin theta. This is 0. R k, theta k. Okay. So what will be IR? That is what how you can. So whenever you go from I to R, what is the radial contribution? So IR will be this multiplied with R, right? So this is sin theta cos phi. JR will be sin theta, sin phi, KR will be cos theta. So we are just looking at the radial component because the question was asking about AR, not the full expression. So that is why we are limiting to this. So we just need to put in this expression. So AR, it was given this is 3x. We need to express x in terms of r theta phi, IR plus 2z r theta phi KR minus 8y r theta phi k. X r theta phi, that is 3 r sin theta cos phi, and IR is sin theta cos phi. So we'll get sin theta cos phi plus 2 z in terms of r theta phi is r cos theta. This is r cos theta, and JR is Sin theta, sin phi. In the last one, we have 8. Y in terms of r theta phi is r sin theta, sin phi, and kr is cos theta. So you will get, this will give 3 r times 1 sin square theta, cos square phi plus 2r sin. Okay. So 2 sin theta cos theta, you can take it as sin 2 theta, sin phi minus. Similarly, 8 cos theta sin theta, you can write it as 4 r sin 2 theta sin phi. So this will be 3r plus 2 theta cos square phi minus 3r sin 2 theta sin phi. So is the problem clear to all? Okay, so uh, if this is clear, then let me go to the next problem. This one is a bit easier. Please go through it once. So it's given rho phi z. These are the cylindrical coordinates, and the equation loci for rho equal to pi and z equal to 0, and the rectangular system is it a circle, or it's a cylinder, or it's a parabola, or it's a straight line? You are given the locus, we have rho equal to 4 and z equal to 0. Option A, circle. Yes, it's correct. Because it's obvious, rho is given, it is 4, and z is also 0. So if you recall, for the cylindrical, we can write it as rho is square root x square plus y square. So this is 4. So if you take the square both sides, it is 16. So this is the equation of a circle. Option A. Okay. Let me move to our next problem. You are given one of the vector representation in Cartesian mode, and you need to find out what is the vector representation in the cylindrical. Okay, so In previous problem, it was given that in the cylindrical coordinates, we have a locus which satisfies rho equal to 4 and z equal to 0. So as I said before, locus is nothing but a path. And in this path, this will remain constant. Okay. So it is given in the cylindrical one. Now it is find out what will be the path in the rectangular system, how this locus will behave, how the path will look like in the rectangular coordinate system. So you are given rho equal to 4, right? So rho, if you recall in the cylindrical one, so this is nothing but square root of x square plus y square. 4, right? So if you take the square, this is x square plus y square, it is 16. So this is nothing but a equation of circle. For ellipse, if you recall, this is nothing but x square by a square plus y square plus b square equal to 1. This is the equation for ellipse. But for circle, we have x square plus y square. These a and b are equal. I think this is clear. Okay, so let us move to our next problem. Similar to the question number 7, now we need to find out what is the component of this vector along the phi direction. So A is given is I cap plus 2z j cap minus 8y k cap. So you need to find out A phi in the cylindrical form. So A phi, to find out A phi, you need to express x in terms of the basis vector of cylindrical one, which is rho phi z. And you need to see how I cap is related to phi. What is the coefficient of, what is the value of the dot product when you take I cap with phi. Okay, so let me see the step first. So this is 2z rho phi z. You need to express j cap in terms of phi, and this is 8y. Need to express in terms of rho phi z and k cap with phi. So the matrix is same for cylindrical one. You have cos phi minus sin phi, sin phi, cos phi. This is 0, 0. This will be 0, 0, 1. So that means from here, k phi it would be. So it is nothing but I cap dot rho cap. Sorry, phi cap. So this will give minus sin phi, right? Similarly, we have j with phi. So this is cos phi. And k cap with phi, this is 0. And if you recall, this is x is nothing but, so x when you write in terms of rho phi z is rho cos phi, and y in terms of rho phi z it is rho sine phi. And z will remain unchanged. So we have a phi. This is 3x rho phi z phi plus 2z rho phi z minus 8 phi. So this will be 0 because this component is 0. Only this will give non-zero value. So this is 3x is rho cos phi, and we have minus sin phi plus 2z cos phi. So we have cos phi minus 3 rho sin phi plus 2z. So this is the final answer we will get. I think the steps are clear. Let me move to our next problem. For this problem, you need to find out what is the separation vector R and what is the unit vector along this separation vector. So you are given a vector, source vector R, which is R cos theta x cap, R sin theta y cap, and there is a field vector. So we'll see what are the source vector and the field vector when we start the electrostatics. For now, just take it as a definition. So this is Z sector. And you need to find out what is the separation vector R and what is the unit vector. Try to solve it first. I think it's not possible to write the answer, so I will go through the answer. So separation vector, if you recall, it is nothing but. So you need to subtract the field vector with the source vector. That is the final point with the initial point. Final point is z secant minus r cos theta x cap plus r sin theta y. So this is the separation vector. For unit vector, if you recall, unit vector is nothing but, so if you divide a vector by its magnitude, then you will get the unit vector for that uh, defined vector. So for separation vector, we need to divide it with the magnitude. So this is z secant minus r cos theta x cap plus r sin theta y cap square root z square plus, so r square cos theta minus this plus r square sin square theta. So this will give z square plus r square square. So that means the final expression is z vector r cos theta x cap plus r sin theta y cap, right? Z square Arts. So is this clear? Okay, so let us move to our next problem. So for this problem, we need to find out what is the angle between the face diagonals of a cube. So you have a cube here. This is X, Y, Z. This point will be for a cube, it is 1, 0, 0. This is 0, 1, 0. This is 0, 0, 1. So what will be the angle between the face diagonal? So don't take one face, take different face. What is the angle between the face diagonals of a different face? Because within a face, if you take this face, the angle will be always be 90. Take any two faces and just calculate what is the angle. Like you can take this face diagonal, and this. And the angle is theta here. Just calculate it. What will be the angle? Only cos inverse minus 1 by 3. Please recheck it once. 1 by 3 or 1 by 2. For this, so whenever this kind of question is asked, what is the angle? So try to think of dot product. So dot product is like this will give what is the smallest angle between any two vectors. Like so here we have two face diagonals. One is, let us say, this is A vector, this is B vector. So try to find out what is the expression of A vector and what is the expression of B vector in the Cartesian coordinate. And if it is not explicitly given in the question, what is the vector, then you can easily find out. Like you know the coordinates, right? So here in this point, this is origin 0, 0, 0, and they for the tail part of this vector, this is in the x-straight plane, so this will be 1, 0, 1. Similarly, for B vector, one point is 0, 0, and the end point is vector ZY plane. So that means this will be 0, 1, 1. So you know what is the starting coordinates of the starting point of the vector and what is the coordinates of end point of a vector. So to find out A, it will be uh, the endpoints minus the final point. That is, endpoint is 101 minus initial point is 000. So that means this will give I cap plus k cap. Similarly, for B, it will be endpoint is 0, 1, 1, and the starting point is 0, 0, 0. So this will be cos inverse half. So try to take the smallest angle first. This is jk plus kk. Because whatever angle the vector makes, we just look at, by definition, we just look at the smallest angle. Other angle, it is like looking at this way, this angle. But we are just looking at this angle, theta, not this angle. Okay, so find out angle. We just need to dot product. So A dot is mod A, mod B, cos theta. So that means cos theta. So always find out the angle using the dot product. We'll see why we don't take the cross product, because the cross product will give two kind of results. Like, so that is why we always look at the dot product. So cos theta is A dot B mod A mod. So A dot B, so we have KK in common. So this will give 1 divided by mod A will be square root 2, mod B will be square root. So this is half. Yes, it is pi by 3. So cos theta is half. So theta will be pi by 3. Okay. So in this question, if you need to find out what is the angle between body diagonals, you can follow the same steps. Like just take two body diagonals and find out what is the, if the expression of this body diagonal is not given, you just look at the coordinates. What are the coordinates? And from the coordinate, you can easily construct what is the vector expression. And from that, take the dot product and find out what is the angle. So for body diagonal also, you can look at this body diagonal and one this body. You know the coordinates. This is origin 0, 0, 0. This is 1, 1, 1. And for this, the starting point is in the z-axis, that is 0, 0, 1. And in the, this is xy, this is in the xy plane. So this is 1, 1, 0. So find out what is the expression for this vector, expression of this vector, and take the dot product. So so I'm leaving this to you to find out. So cos theta, you will get 1 by 3 here. So theta will be cos inverse 1 by 3, which is around 70 degrees. Okay, so let us move to our next problem. For this one, you need to find out what is the unit vector in this following figure. So you are given a reason, shaded reason, which is this blue spot. And this unit vector nk, it is pointing uh, outward to the shaded plane. Okay, so you mean this slide, or I need to go back further? Do you have any doubt in any of the states? Okay, for this question, you are given a reason in the XYZ plane. You are given a plane, and this unit vector, it is pointing away from this. It is pointing outward to this plane. So you need to find out what is this unit vector. Uh, there is, sorry, the marker, I think. So do you have any query? So let me unmute you first. You can speak now.
Ma'am, here we are yet to find the area of this triangle thing, right, ma'am?
Uh, area, yes, you are right, but area is
Not
needed
required.
actually.
Okay.
Yeah. So if you recall the cross product, like
The
A cross
scalar
B,
triple product. Oh, so or the vector triple product, I guess. Yeah.
it's not the different product. It's like only the cross product of two vectors. So if you
Mm.
recall the definition of this cross product, it's like A cross B, it's mod A,
Mm.
mod B, sin theta,
Yeah.
n k, right?
Okay. Okay.
Or yes, and this is nothing but the magnitude of the area you are talking about.
Okay.
Hmm. And this n cap, it is, if you recall, it is always perpendicular to the vector we are considering or the plane which is these two vectors. So if you anyhow find out what is A cross B and what is the mod of or the area you are talking about, if you find
Mm-mm.
out this, then you can easily find out what is NK. But if you don't know the area, so first thing you need to look for two vectors in this plane. So if you are in this figure, you are not given any vectors. So
Yeah.
you can easily whatever vector you want, you can easily take it, and so just like you can take these vectors. Let me okay, take these vectors, or this is as a vector, or this is as a vector. Take any
Okay.
two vectors, find out the cross product, and find out the NK.
Okay. Okay.
Hmm.
I'm clear with this.
Okay. So as I said, you need to find out what are the expression of two vectors and what is the magnitude of this cross product. So so for finding out the two vectors, you need to find out the coordinate first. So let me take this is as a vector and this one as a vector. So this is 100 and this one is z direction. So this will be 003. So that means area A vector, this is final point minus initial point, right? That is 003 minus 100. So this will give minus I cap plus 3 kk. So this is the shorthand notation I'm using. So remember we have I cap, j cap in each of these components. Okay. Okay. Now for B, this is the initial point is 100 and the final point is 020. So that means for B, we have final point 020 and initial point is 100. So this will give I cap plus 2j. Now you know the vectors and the expression. Now you can easily find out what is A cross B and what is the mod of A cross B. I think everyone is comfortable in finding A cross B now because we can take find out. This is one of the easiest way you can find out. Don't use the legacy beta symbol because it may be confusing to find out. Whenever proof is required, you can use the legacy beta symbol, but whenever you are solving a numerical problem, try to use this formulation. So for I kept one, this is 0, this is 3, and 1, 2, 0. So we have 6 IK plus 3 JK plus 2 KK. So this is A cross B. Now you need to find out what is the mod, which is easy for you also. This is 6 square plus 3 square plus 2 square. So this will give 7, I think. 36, 9, 4. Plus 49, so it will give 7. So now the unit vector is A cross B by mod. B vector is minus I cap. Okay, this is minus. So this will be minus also. So we have now, I think this is fine. I think only I have mistyped this one. Otherwise, the answer is this is 3. KK will give minus 2. Mm, 0, 2, 0. Okay, so I think this will give minus 2. Zero, 0, 3 minus 1, 0, 0. Also minus 6 side. Yes, I think 3J it's also minus. No, this is fine. This is 0, 0, 3, 1, 0, 0. We will get 3 I minus I plus 1, 0, 0 minus 0, 2, 0 minus I plus 2 J. So this will give minus 1, 0, 3 minus 1, 2, 0. For I cap it is minus 6 sign and J cap it is minus 3 minus plus 3 and for K cap it is minus 2. Okay. So the answer will be minus 6 I cap plus 2 J cap. Okay. So I think I made a small mistake here. So the vectors that we consider, it's like I have taken one vector in this direction, which is A, and I have taken one vector in B direction. But if you see the NKP, it is pointing outward, right? So that means when you take the cross product of A cross B, it should point in the outward direction. But the way I have defined the vector, if you take the cross product, it's like it is pointing opposite. So that is why whenever you are taking the mistake only here is taking A cross B. So instead of A cross B, you need to take B cross A to see to get this value in K. Okay. So don't take A cross B because it's the magnitude will be same, but only the direction will be opposite. So if you take B cross A, this is B cross A. So now B minus 1 to 0, and this is minus 1, 0, 3. So this will give, I think now this will give 6 I cap plus 3 j cap plus 2 cap. The magnitude is same, it will be 7. So B cross A is 7. So here it is plus. Okay. So is this clear? So this is the final expression that you need to do. Is any one of you have any doubts? So just look at the direction of vector also, because if you take A cross B, then it's like the direction is opposite. Although you will get the same magnitude, but the direction will be opposite. Okay, so just whenever you are trying to solve, look at the direction also, in which whether your vectors is getting the is giving the same direction that the question is asking about. How do you find the direction? So direction, it's like taking the cross product. So if you point the, so you need to use your right hand. So you need to, let us say you are finding the direction of A cross B. So just place your fingers parallel to A and try to call it along B. So for this case, A is in the up direction and you are trying to uh, call it in the B direction. So it is pointing inward, right? But if B is in the top, so B is in the top and you are curling along A. So that is in the, it is in the, sorry, B is in the below and you are curling along A. So it is pointing away from the plane. Or you can use the right hand rule. So this is the right hand rule. Okay. If it is clear, then let us move to our next problem. This one is easy. You just need to see what are the relation between rectangular and the cylindrical one. So you are given a rectangular coordinates described by y is square root 3x, z is 5. And you need to find out what is the cylindrical coordinates in the of the surface. That is, what is the value of 5 and what is the value of z. Z will remain unchanged when you go from the Cartesian to cylindrical. So that is why you can see Z is same here. Only you need to find out what is how. So let me quickly. So phi, this is tan inverse y by x, which is tan inverse square root 3x by x. So this is tan inverse minus root 3, which will give 2 pi by 3. Option B. Option B, 4 pi by 3. So you have taken twice of 4 pi by 3. So you need to look for the smallest angle. Okay. Which part you need to see? This part. Okay, current question. Is this clear? Okay, so let us move to our next problem. Next problem is the proof. This question that I think you must have solved it during your school days. Like whenever you have a triangle, so you have a triangle, let's say ABC, and you join the midpoint of this with the midpoint of this. So this vector it is parallel to this vector, and the length, the magnitude will be half of it value of this base. So this you can solve it using the vector law. So you have a triangle like this and another triangle like this. For let us say this is C, this is A vector and this is the B vector. Let's take this is D, this is C, and this is D and D. The magnitude is D. So from this triangle, so if you recall the vector uh, addition, it's like if you add these vectors A plus B plus C, so this form a closed path. So that means A plus B plus C, this is 0. So A will be minus of B plus C. In the small triangle ADE, similar way, so AD will be half of C and AE is half of B. So that means D plus half of C plus half of E, it is 0. So D by 2. So D will get minus of half of B plus C. This is nothing but half of A, right? So D plus half of A. So that means this vector, the vector here, it is parallel to BC and it is the value, the magnitude will be half of A. So I have, I think, three more problems to solve, but I think the time is also over. So let me solve it in our next part, next tutorial, or if possible, please try to go through it once. So I will upload the files in my Google Drive link. So soon this link will be shared with you. So please try to wait for some time, then the link will be shared with you. And um, okay, so do you, before closing the session, do you have any doubts, any other doubts, or in any of the problems you face, any difficulties? The next tutorial will basically see what is the divergence, what is curl, what is the divergence theorem. Any of you have any doubts? If not, then we'll end the live session and we'll meet on next Friday. Same timing from 6 to 8. Okay, I think you don't have any questions. Okay, so Thank you for joining the session. I think the questions are clear to you. And please try to join the next session also, which will be on next Friday from same time, 6 to 8. Okay. So, bye everyone. Let's meet on next Friday.